Before I start this video, there's one thing you need to know. Perspective in all 2D game art is weird. It's weird in side-scrollers and it's weird in top-down. But in this video, I'm going to try and cover perspective in top-down games. And here I'm not referring to top-down games you see in Might of Merchants or GTA 2, but the type of perspective you would see in Stardew Valley or Zelda. So I'm going to start this by covering the concepts behind this perspective. And I'll be making some infographics that you can download for free on my Patreon as well. That when we're doing game art, we generally don't deal with perspective in the way you might have been taught in school. If you were to learn traditional art, you would learn about 1-point perspective or 2-point perspective. And if you were to paint a house in 2-point perspective, you would mark where your horizon is, and all these lines would converge at a point somewhere on the horizon line. And all these lines would also converge towards a point. This is all very similar to how we see the natural world. Things get smaller the further away they are. So this box looks big on screen here, but the further back I move it, the smaller it gets. This doesn't work in 2D games. Suppose you drew a top-down version of this house in normal perspective, and then you had a rock like this. Now if you wanted to reuse this rock asset further into the distance, you can't just copy it and move it. You also have to scale it down and make it smaller. Having the same rock be really big when you're close to it, and really small when you're far away from it, would mean that you have to scale your sprite in real time as you move, and at that point it would just be smarter to use 3D. So what we do instead is we use something called parallel projections. Now instead of our lines pointing toward a vanishing point, they're just always parallel with each other. So if I change this same angle to a parallel projection, we would get this. We can see that these roof lines here are completely parallel with each other. But more than that, now we can take this rock here, copy it, and place it here, and here. And it always stays the same. So I can reuse this asset without having to scale it, which is great. Swapping between this view and this view makes our projection look kind of off, but you can see how games often do have something similar to this kind of view. Now there are lots of different parallel projections. Isometric is such a common projection that we actually name it, even though a lot of isometric games are actually dimetric, but that is not the point of this video. In top-down games like Stardew Valley or Fields of Mystria, we tend to want to see the roof and the walls of a building at the same time. But once again, we can't have the scaling problem we get with normal perspective. So we tend to use a projection where the z-axis and the y-axis align or overlap. So if this is our x-axis, then we have our y-axis here and our z-axis here, our height and our depth. These two overlap. What often gets confusing about this top-down view is that top-down games such as Fields of Mystria, Eastward, and Hyper Light Drifter could look superficially similar, but these games sometimes use two different types of projections. So you will sometimes see this top-down view called oblique top-down, and then you'll sometimes hear the term 3/4 axonometric perspective, or orthographic perspective. These are superficially similar, so it's easy to confuse them. If we look back to our house, if this is our natural perspective, then this is what we would call a 3/4 axonometric perspective, and this odd view is an oblique top-down view. Now you might think that no one would draw in this odd oblique projection, but this projection is used more often than you might think. So what is the difference between these two houses? Well, I'll start out with the odd-looking oblique perspective. If we just imagine that the width of this house is 1, the height is 1, and the depth is 1. Well then for our oblique perspective, if the x-axis has a length of 1, then the y and z-axis will also have a length of 1. This means that in our oblique projection, our dimensions are kept proportional. And so our house can be drawn as if you're looking at it from the front, and then the top, and then you staple them together. Which we can see. This is our front view, and this is our oblique top-down view. There's only a small difference between the two, and that is that this roof actually sticks out, so will be positioned slightly lower than it would on the front view. Same thing goes for the chimney and the window. They still look the same, but instead of the chimney being here, it's significantly further up. But other than that, the proportions are kept the same. So the view looks fairly identical. So drawing a box in this perspective can look kind of weird. But at the same time, it's rather easy to do. You just take the front view of a box, and then the top view of a box. You stitch it together, and there you have it. A top-down box. Okay, but what about our other projection? Our axonometric projection? Well, the underlying principle is the same. But when we do this projection, our y and z axis will get kind of squished. So if our house has the height of 1, then in our top-down view, it will instead have the height of 3/4 of that. And the same thing happens for our depth. Instead of the length of our house being 1, it now looks as if it's 0.75. So we get some foreshortening. But other than that, same as before, it's almost as if we take the top view and the front view and stitch them together. So in this case, our axonometric house is slightly more squished because of foreshortening, and thus looks a bit better. So you could technically kind of start drawing if you just know this. But I think there's some more stuff that could be useful to know. And so we will start with talking about why this happens. So let's start with our axonometric projection, the projection where we get this foreshortening. So in order to get these type of fake perspectives that is somewhat different from how we view the world around us, we actually translate the 3D object onto a plane using graphical projections. We can kind of think of it as this plane being the paper that we draw on. And we just try to imagine what this paper would see if this point was translated onto this point on our paper, this point to this point, and this point to this point. Now in this particular example, all of these translation lines, these red lines here, are parallel with each other, and the lines themselves are orthogonal to our projection plane. It's orthogonal to our paper. And if you look at what this type of projection produces, well, we get our axonometric perspective. You'll sometimes hear this perspective called orthographic projection. An axonometric projection is a type of orthographic projection, and this orthographic comes from our plane here being orthogonal to our projection lines. So in order to understand why we get this foreshortening in this perspective, we can look back to our house. As we said, our house has the height of 1 and the depth of 1. But the image we are projecting onto the plane, onto our paper, is only as wide as the diagonal of this house. Now, Pythagoras' theorem tells us that this diagonal is square root of 2. And so each side here that we're projecting onto our image, our z-axis and our y-axis, will be half of that, square root of 2 over 2. Now I mentioned before that our foreshortening factor is 3/4, and square root of 2 over 2 is not 3/4. It's not 0.75, but closer to 0.71. I don't actually know where this 3/4 come from. I might be wrong, but I think that this 3/4 tend to be used only because pixel art really can't foreshorten by 0.71, and 0.75 is a fairly decent approximation. But it's important to note here that this situation where both the z-axis and the y-axis are foreshortened by the same amount only happens when our axonometric projection is set to 45 degrees. So if this angle here is 45 degrees. If I lower my angle, suddenly my roof gets really squished, whereas my front starts losing that squish. So some top-down games uses this axonometric projection, but they aren't 3/4 axonometric. For instance, you might see a game with this type of view, where we see almost the entire roof, but the walls are really short. The walls are really foreshortened. Here I'm drawing this house at a 67.5 degree angle, instead of what we would get if I drew this house at a 45 degree angle. Both views are axonometric, but they also look quite different. Same projection, different angle. So what about our oblique projection then? Well, we still have a plane we are projecting the image onto. We still imagine that this is our canvas. But instead of our plane being angled like this, it's placed like this. Oblique just means our projection plane is skewed, so our projection line here is no longer orthogonal to the plane. So what happens if we're still looking at it from that 45 degree angle, but now our plane is parallel to the y-axis? Now we have a 45 degree angle here and a 45 degree angle here. Well, in an oblique projection, we actually also deal with a foreshortening factor, but this foreshortening factor is inversely proportional to the tangent of this angle. It just so happens that if our angle here is 45 degrees, then we get tan of 45, which is 1. So our foreshortening factor here is 1, and if we foreshorten the length of 1 by 1, we get 1. So when we draw in the most common top-down oblique projection, the x dimension is 1, the y dimension is 1, and the z dimension is 1. Basically, you draw any object as if you're looking at it from straight on. But you could technically have a different angle than 45 here, and if you do, your foreshortening factor will be different, and so your projection will be different. So we have two types of projection that kind of represent the same world. One with foreshortening and one without. So how do you tell the difference between the two? Well, the easiest way to spot if a game uses an oblique projection is to look for an object that should be completely round. So, a cup. If the top of this cup is still round looking in the game, if it's still a circle, then we're probably dealing with an oblique projection. So if we look at Stardew Valley, this window is circular, this stump is circular, these logs are circular, so it kind of looks like Stardew Valley uses an oblique projection. If we compare this with an axonometric projection, a circle would tend to look more elliptic like this. We have some foreshortening going on. So here in Fields of Mystria, these logs would probably naturally be kind of circular like, but here they look elliptical. So it looks like Fields of Mystria uses an axonometric projection. So this is the idea of it. But the thing that happens is that these rules are broken all the time. For starters, as I said, with an oblique projection, we expect cylindrical objects to look like circles on the top. And for an axonometric projection, we expect some foreshortening. But if we take a look at Fields of Mystria again, this is elliptical, this is also elliptical. There's definitely some foreshortening going on here. But here we have almost no foreshortening. Here there's definitely no foreshortening, except, nope, once again, this is very foreshortened. This is somewhat foreshortened, whereas this is extremely foreshortened. Same thing also happens to Stardew Valley. This window is definitely not squished, whereas this bowl that I conveniently ignored earlier is definitely elliptical. So you can see that while we start out with a kind of simple projection rule, these two projections are mixed all the time. Sometimes it's axonometric, sometimes it's oblique, and these projections aren't just mixed between assets, but sometimes the same individual asset can have a weird projection if you stop and think about it. If we look back to our reasonable looking house that I showed earlier, when we projected this house with an oblique projection, our house got really long. And if we look at this house in Stardew Valley, well, it isn't long at all. So either they use a weird oblique projection, or this is an extremely short house. Further than the parallel projections often being mixed, even the basic idea that our lines are always parallel sometimes also start to break. Look at the angle of these houses. The lines here are clearly starting to point toward a vanishing point. They're not straight. So what they're trying to do here is fake extra depth by emulating traditional perspective. And the thing is, that can be kind of cool. If we take our boring axonometric 45-degree house and just push in the walls a bit, the house actually starts to look kind of nicer. The rest of the game is still axonometric, but we add some normal perspective to some objects here and there, just to spice up our game a bit. So while I started out by giving you the maths of these projections, the simple fact is that the artist creates the world, and the artist mainly cares about it looking nice. And that means that the artists often break these rules, either intentionally or unintentionally. You might think that this is a problem, but it can often be difficult to notice these errors unless you actively look for them. And as I said, with our house example, this incorrect version actually kind of looks nicer. So there can often be a good reason to break the rules. And if you want to get technical about it, since the difference between these projections only affects our foreshortening, if our underlying world is weird looking, we can't even tell which projection we are dealing with. Why? Well, as I said, we have mostly been projecting this house from a 45-degree angle. But as I mentioned earlier, if we change the angle, we also change the amount we foreshorten the object. So for our other house I showed earlier, our angle here is 45-degree axonometric, the standard 3/4 projection. It looks fine, but suppose I don't like how the side of the roof is cut off, and I want to see more of it. Well, as I showed you earlier, here we have a 67-degree angle, and now we see more of the roof. So less foreshortening on the roof, but there's significantly more foreshortening on the wall. But what happens if I take my house, which kind of looks like this from the front, and I make it twice as tall? I stretch everything. Now if we look at it from this 67-degree angle, now I see quite a bit of my wall, and quite a bit of my roof. My projection is still correct, but my underlying world is strange. Everything is twice as tall as it should be. But the more important question is, how incorrect do you think that this looks? If I were to just casually see this, I probably wouldn't notice anything wrong. In fact, I can't personally draw all of this consistently in my head and be able to give you exact angles. So all of the house examples I've shown you were drawn on top of screenshots from some Blender models I made, which is why I could give you all these angles. So for this last example, I just multiplied the height of the wall by 2, which makes this 3D model extremely weird looking. But if you were to just look at this single image, I'm not sure most could tell that this is weird. This is kind of important to keep in mind. Like, look at this example. What is the difference between this square and this square? Well, it doesn't look like there's much of a difference from this angle, but if I shift it, we can see that I'm just combating the foreshortening by altering the scale. So in practice, I frankly think you can get away with not keeping a consistent angle or a consistent projection, as long as the audience doesn't notice it. Technically speaking, I'm even speculating when I'm looking at this example in Stardew Valley and saying that it's an oblique projection. Even though this looks circular, suppose I take my house model and half the length of the house and double the height of the house. Now the house itself has an elliptical window here, and so when I look at it from my 70-degree angle with my axonometric projection, well, now it looks perfectly nice and also kind of like an oblique projection. My point is that if your art looks kind of fine, then it is kind of fine. As I said, most games tend to prioritize design and aesthetics above accuracy, as they should. Even when drawing, I think most people draw based on intuition, which means artists only notice mistakes that are obvious to them. So for some of you, this might look really off, but for some of you, you wouldn't give it a second thought. All of this that I've talked about will also relate to your characters. Take a look at this dog. What should you do if the design of this dog looks better inside view compared to a 3/4 view? This dog is absurdly incorrect in this context. We have no top-down, only side view. But the question is, Which version of the dog do you prefer? If it's too bad, people will complain and then you fix it. But if you feel like you don't know quite how to do this correctly, I wouldn't worry. It's better to get started and make something wrong than to not make anything. Eventually, you'll start to build some intuition for it. Now, given all of this, when we are dealing with any type of parallel projection, what we gain by not having to care about scaling, we lose in the fact that it becomes very difficult to ascertain depth. A game designer of Hyperlight Drifter even mentioned this in a GDC talk. She mentioned that she tried looking at level design in SketchUp just in order to be able to differentiate between different heights. This means that a lot of depth when we make our assets actually comes from lighting, and so lighting becomes important. Luckily, I think lighting in top-down games tend to be quite intuitive. You just kind of pick a lighter color for the XZ plane and a darker color for the XY plane. The only thing you need to keep track of is which plane you're working on. But whereas you can kind of ignore lighting completely in side-scrollers, I feel that lighting becomes difficult to ignore completely in a top-down game. It becomes tricky to differentiate between our walls and our roofs. So there's one thing with these type of projections that I find can get really tricky. And that is when you start introducing angles in your objects. So if we have a roof angle in this direction, this is simple. We can see the angle here. But suppose we're looking at this house from this angle. How much foreshortening are we getting on this end compared to this side? Well, it depends both on the angle of our projection and on the angle of the roof. Basically, I don't have an easy answer on how to do this completely accurately, but if we look at what happens if we look at this house from the side at our standard 3/4 angle, the back side completely disappears. We only see the side with the chimney on. This essentially happens because the angle of our roof is higher than our angle of projection. So the angle of our roof is more than 45 degrees. As you can see, this looks awful. So if you wanted to draw a house like this from the side, you would kind of have to shorten the angle of the roof. If we had a roof with a smaller angle like this, now from the same angle of projection, our roof would instead look like this, which is significantly better, even though it isn't necessarily nice looking. What's important to keep in mind in a scenario like this is that the edge of the middle of our roof doesn't actually end up in the middle. It looks as if it's further up. Consequently, this side will be significantly more foreshortened than usual, and on the other end, this other side of the roof actually becomes significantly less foreshortened. So even if our angle of projection tells us that we should foreshorten things by 0.7, when we start introducing angles on top of our projection, things can change. Even though I don't know exactly how to calculate this, I think you can kind of freehand it by just adding some foreshortening on one side and placing the center of your roof slightly higher up than the middle point. Or you could just avoid these type of angles, because this is an extremely important point. Your end goal is to make a pretty asset. Even if this asset is correct, it's also ugly. In fact, even this house is kind of ugly in terms of an asset, because I just made it in order to illustrate the projection. And the best version of this house that I've made happens to be the incorrect one, where I emulated actual perspective. Now for this house, I think this vibe kind of works. But none of this house looking kind of decent has much to do with our accuracy in itself. It's largely about the small things I added, like this axe or this mailbox. This underlying house actually looks almost equally bad and boring compared to this red house if we remove all the nice stuff to it. Top down can easily look weird even when it's accurate, so keep in mind that you need to think about the design. If you do want to build more complex intuition for this type of perspective, I recommend two things. First of all, look at other games and look at how they made their game art. Analyzing other games and trying to make sense of them can be helpful, not just in terms of learning what works, but it can also give you some ideas. For instance, I really like the look of Fields of Mystria, and this idea of drawing your house as if it kind of has a vanishing point kind of works. I like this idea. So if you take these ideas and how a game like Fields of Mystria creates houses in this perspective, you can kind of create your own houses following the same principle. The second thing I recommend that you do is potentially just play around with Blender or similar 3D software. I still suck at Blender. I used Google SketchUp for 15 years, but I think creating these basic 3D models isn't too difficult. Now if you're doing an orthographic projection, you need to set your camera to be orthographic. And if you want to create an axonometric 3/4 perspective, just rotate your camera to 45 degrees. Or a different angle if you don't want that 45-degree look. Now if you do want to use an oblique projection, keep the same 45-degree angle, but just make sure to scale your axis by square root of 2 to get rid of that foreshortening. Now if you do this, the scaling of the object itself will look weird. But from the point of view of the projection, it looks accurate. As a side note, you can technically even create games like this completely in 3D. Enter the Gungeon is probably the most famous example, and was done in 3D in order to have an easier time handling sorting orders. Basically, there are games out there that simulate this 2D look, but that were actually made in 3D. They look similar, but they were also forced to play around with some stuff like rotating the walls 45 degrees in order to project the walls correctly onto the plane. So as a curious tangent, if you look at how I talked about our projections, I kind of framed it as if we're translating the world using weird math, which in a sense we are. But our natural perspective also kind of works like this. So if I were to draw kind of how a perspective projection looks, we would have a center of projection over here, and then our projection plane over here. And all our projection lines would line up at this center of projection. The distance between our center of projection and our projection plane is called our focal length, whereas this angle is called our field of view. Both of these terms are things you might have heard in photography. So what happens if our center of projection is really far away? Well, now our focal length increases and the projection lines start to become significantly closer to being parallel. And if we extend our focal length to infinity and make our field of view 0, well, then we have a parallel projection. This is in a sense just a curious tangent, but what's kind of interesting is that this kind of means that if you take a camera and zoom in on something far into the distance, what you will see will actually start to resemble a parallel projection. There's one thing I think you should be careful with, and that's mixing two foreshortening factors next to each other. So if you have one object with very little foreshortening and another object with a lot of foreshortening, these two won't mix that well. It will look off. It will look as if you have two different angles going on. So as a disclaimer, I'm not the best at this stuff. This was more of a beginner overview on how to avoid the biggest mistakes. This is not something I sit and ponder on the regular. If you look at my channel, you can see that I personally mostly cover side-scroller art. But I also feel as if there isn't that much info on this topic. So I thought I'd cover my understanding of it. With that said, I might have made a mistake myself. If you feel like I missed something or made a mistake, please correct me and I'll pin a correction in the comment. Feel free to support me on Patreon, it really helps. I make some unscripted content on there, and as I said, I will publish some infographics from this topic for free on there. You don't have to become a member to download it. Thanks for watching. Bye.